So hello everyone, welcome to OneClass YouTube channel. My name is Devansh, a senior tutor at OneClass, and so today in this session we'll go through a couple of calculus questions, and these questions are mostly going to be at high school and university level. And so a little bit background about myself. So I am in the final year of my graduation, and I am doing my graduation in aerospace engineering. And if you need any tutoring help, or if you need any one-to-one live sessions, then you can check the links in the description below. And so without wasting your time, let's just begin with our chapter today. So, um, yeah. So we have the first question here with us. I'm just so it says that horizontal tangent lines show that the graph of the function f of x is 3x plus sine x plus 2 does not have a horizontal tangent line. Okay, so basically what is saying that we have a function which is function of x which is 3x plus sine x plus 2 and does not have a horizontal tangent line. So to find the to find the slope or to find the slope of the tangent line or to find the tangent lines at any point, what we do is that we just divide or we just differentiate this function. So we'll just take a derivative of this function. Okay, so d dx of f of x is this will be 3 only, plus this will be sine will convert it to cosine of x, and 2 will be nothing but 0. Now what we do is that we equate this. So basically for suppose let's say this is let's say this is a graph. Okay, now at this point my slope is this, at this point slope will be this point this will be tangent line, at this point this will be tangent line. Now it is asking for horizontal tangent line, and horizontal tangent lines basically lie at maxima and minima. So let's say this was our graph. Okay, so we can clearly see that this is our local minima, this one is our local maxima. So I if I just um, make these the tangents at this point, then these tangents are going to be horizontal lines. Now how do we evaluate the tangent of any function, or the horizontal tangent or maxima or minima, is that we equate the derivative to 0. So this was the derivative which we calculated, so I'll just equate this to 0. So this will be 3 plus cosine x will be 0. Now with this we solve for x and find the values at we find the coordinates at which um, the function is having a local minima or maxima. So if I just subtract 3 from both the sides, then I'll get cos x equal to minus of 3. Now the thing is that the range of cosine is from -1 to 1. So the minimum value of cosine can be -1 only, and maximum value can be +1 only. But in this case we are getting cosine as -3, and this is not possible obviously, because it is out of the range of, or out of the domain of the cosine. So we can say that for no value of x, this condition can be satisfied. So basically there is no horizontal tangent line. And here in the solution also it is given that derivative of function, they have calculated derivative equated to 0. This is not possible as the range of cosine x for all x is -1 to 1. Thus the given function does not have a horizontal line. So no horizontal tangent. Mm, so that is pretty much everything for this one. Just a minute. Just a minute. Just a minute. Yeah, where is my cursor? Yeah. So I can just say that the solution given here is correct. So correct solution is given here. Nice work. And solution is correct. Okay, we have another question here. So this is going to be our question number 2, and so we need to use implicit differentiation to find dy by dx and d square y by dx square at the point 1 comma 0 for y square plus 1 equal to x e power 2y. So first I'll write the function. Function of fx is y square plus 1 equal to x times e power 2y, and we need to calculate dy by dx and d square y by dx square. So first, for calculating dy by dx, what we'll do, we'll just differentiate this function. And now this is not a normal kind of differentiation. We are basically doing differentiation with respect to x on both the sides. So here I'll use the power rule here. So this will become 2y, and then differentiation of y with respect to x, so it will be dy by dx, plus differentiation of 1 is 0 equal to, now at this step we'll be using product rule. So it will be like first we'll keep x constant and we'll differentiate e power 2y, then we'll keep e power 2y constant and we'll differentiate x. Now again I'll just write this 2y dy by dx equal to x time. Now differentiation of e power anything is like e power x is e power x only, but here we have a constant number multiplied with the variable, so it will just come down. So differentiation of e power 2y will be 2 times e power 2y. So this will be 2 times e power 2y, and then we'll again write dy by dx because this was a function of y. This e power 2y was a function of y. So dy by dx and then plus e power 2y, and then we'll differentiate this, and this will be differentiation of x with respect to x will be 1 only. So we'll have 1. Now I'm going to rearrange this equation. So basically I'll take this whole term on the left hand side, so it will become 2y dy by dx, but we need to keep this equation because for calculating d square y by dx square we'll be continuing from this equation only. But to calculate dy by dx at 1 comma 0, I am going with this step. So I'll just take, this will be 2 times x e power 2y dx equal to e power 2y. Now I'll take dy by dx common, so this will become, this is 2y minus 2x e power 2y, and this will be e power 2y. Now I'll divide both the sides with this these two terms or this expression. So I'll just divide both the sides with 2y minus 2x e power 2y. This one also. So finally I'll get an equation for dy by dx. This will be e power 2y over minus 2x e power 2y. Now we need to calculate this at point 1 comma 0. So for at x equal to 1 and y equal to 0, we'll just substitute x equal to 1 and y equal to 0 in this. So this will become dy by dx at x 1 comma 0 is e power 2 times 0 over 2 times 0 minus 2 times 1 times e power 2 times 0. Now e 2 times 0 will be 0 only, and e power 0 will be 1. So this will be 1 over, this will be 0, 2 into 0, and this again e power 2 into 0 will be 1 here, and this 2 into 1 will be 2. So we'll get minus 2 in the denominator, and this is the solution for, so the value of dy by dx at 1 comma 0 for this expression or this equation is negative of 1 over 2. Now we'll using this value also in later steps. So we have completed half of the equation. Now I'll continue with this equation. Which one? I guess we'll continue with this one. So I'll just rewrite this 2y. Is it a better idea? Okay, let's just do one thing. We'll continue with this one. So this is 2y dy by dx. I just take a shortcut. Just a minute. I'm just copying this equation. Now I'll again differentiate this equation with respect to x, and now we'll have some kind of special treatment for this dy by dx terms. So basically, when we differentiate, then 2y is taken as another function and dy by dx is another function. So we'll use the chain rule between 2y and dy by dx, or the product rule between 2y and dy by dx. So first we'll keep 2y constant, and this will be differentiation of dy by dx is nothing but, I'll just plus, now dy by dx is kept constant, and we differentiate 2y with respect to x. And again this okay, so we'll do this in another step, and this will be now x e power 2y. Here also we are going to use the chain rule, but here we have three functions. Let's say first one is 2x, then we have e power 2y, and then the third one is dy by dx. So I'll keep the first I'll just differentiate the first one. So this will be, or it is better to keep 2 outside the differentiation. So e power 2y dy by dx, and this will be dx by dx plus we'll keep dy by dx and x constant, so x times dy by dx times d dx of e power 2y plus I'll keep these two constants, so this will be x times e power 2y and differentiation of dy by dx, and this will be um, d dx of e power 2y. Now I'll just start with the differentiation process. So this is 2y, this will become d square y by dx square. D square y by dx square plus this will be differentiation of 2y will be 2, and this will be 2 times dy by dx, and we have one more dy by dx. So I'll just write this stepwise. So this will be 2 times dy by dx equal to 2, and then this is e power 2y, so this will, we have dy by dx, and this differentiation of x is 1 plus this will be again x times dy by dx, and this will be 2 times dy by dx, and then plus, and this will be x e power 2y d square y dx square, and then this will be plus 2 times e power 2y now I'll just multiply this dy by dx, or um, instead of doing that, let's just keep the values. So we have the value y is 0, and dy by dx we calculated for 1 comma 0 was negative of 1 over 2, and then x was 1, so let's keep the values here. So this will become 2 times 0 times d square y by dx square plus minus 1 over 2 into 2 into minus 1 over 2, 2 times e power 2 into 0, and this was minus 1 over 2 plus x was 1, this was minus 1 over 2, and this was 2, and this was again minus 1 over 2, then plus 1 e power I should have a e power this this should be, yeah, okay, I should have one e power 2y also, 2y, yep. So this will be e power 2 into 0, and here we'll have x is 1, e power 2 into 0, and dx square, this is plus 2, and this will be e power 2 into 0, and this was negative of 1 over 2. Now I'll just go for, so this term will be gone because this is 0, and 2 can get cancelled, this will be 1, and this 2 can get cancelled, this minus minus will become plus, this minus and minus will become plus, and this will go to 0, sorry, this will go to 1, and This will also go to 1. This 2 and 2 get cancelled. So let's see at the end what we are left with. So this term is gone. This will be 1 over 2. Then 2 times this is this will be negative 1 over 2. This will be minus minus cancel, positive 1 over 2. Again this term will be 1. So this is positive 1 over 2 and these both will equal to 0. And plus we have 1 times d, and this will be minus of 1. So I can add 1 on both the sides, and okay, so after adding this will become 3 by 2 equal to this, and this will get cancelled. 2 times d square y dx square, this will become, just divide both the sides with 2, 3 over 4. So this should be the answer given here. So finally we have also completed the second part. So for first part, dy by dx was negative 1 over 2 and d square y by dx square is 3 over 4. Now I'll just check the solution given by junior tutor also. Okay, so they have also done the same thing, and yeah, they are also getting the same answer, so I can just say that correct solution. Good work. And this was question number 2. Yep. So we have question number 3. So for question number 3, we need to find the antiderivative of tangent of x. So antiderivative means integral of tangent of x. So basically first I'll write tangent of x is sine x over cosine x. So I'll substitute the value of tangent as sine x over cosine x. So this will become sine x over cosine x dx. Now the thing is that for tangent we do not have any direct formula, but this can act as a direct formula because this is a kind of derivation, and when we were in our high school, like we never used to go for such kind of derivations because we already memorized the value of this integral of tangent of x. But yeah, this is the best approach. Like sometimes I also tend to forget in the exam, and at that time I'll just do a quick derivation and find the value of the of such kind of expressions. Now what I'll do, let's keep cosine x. So let's say cosine x as u, and let's take the derivative on both the sides. So this will become minus sine x dx equal to du, and let's divide both the sides with negative of sine x. So this will become dx equal to du over negative of sine x. Now let's keep the value of cos x. So this will become sine x over u, and we'll substitute the value of dx. So dx was du over minus of sine x. So I can just cancel these two and I will get minus of du over u. Now I know that the integral of dx over x is ln of x. So in this case, integral of du over u will be minus of ln of u. And we'll okay, so we'll add the constant of integration at in the last step. So remember one thing always, that whenever you are doing the integration, and like whenever you are using the log, then always write ln instead of log, because the thing is that in most of the places, if you are just writing log, then it is thought, it is like assume that the log without any base is basically log base 10, and ln is the natural log. So that's why always remember to write this ln, because in integration we always end up with ln, not with log base 10, obviously, until and unless you convert it in the log base 10. Now I'm going to substitute the value of u, so that was, and now in the final I'll just write the constant of um, integration. So this is minus of ln of cos x plus c. So I can write integration of tangent x dx is negative ln of cosine x plus c. So let's just see what the solution is given. So you can also see that the in the solution given by Junior Tutor, um, they have also mentioned ln instead of log. And yeah, always write a magnitude also, because in integration we get the inside, like when we do the integration we always write the inside value in modulus. So this is ln of cosine of x plus c. Okay, again correct solution given here. Nice work. In the same way, you can find the integral of cotangent of x, and that will be ln of sine x. You just need to substitute sine x as u, and then you will get the answer. Now we'll have question number 4. Now, what is the limit as x approaches infinity of sine x? So we need to find limit x approaches to infinity of sine x. I think yeah. So we need to find this. So basically, the thing is that the maximum and minimum value of sine is like minimum value is 1 and maximum value is positive 1. Minimum value is negative 1 and positive is maximum value is positive 1. So the like it clearly says that the domain of sine x is from negative 1 to positive 1. So x will, like, it will never have a value at infinity, and therefore we can clearly say that this will not exist. Like if it was tangent, like the graph of tangent is like this, um, is like this. For tangent, for the case of tangent or cotangent, we we always get an absent asymptote, and we can find the value when x is approaching to infinity. But for sine and cosine, we have a sinusoidal wave, and it has a maximum amplitude of 1 and minimum of negative 1. So we'll never get so the sine will never touch the infinity terms until and unless we have another function where it is added or subtracted with infinity or tangent or some kind of function, but for this one the value will not exist. And here also, as x approaches to infinity, the y value oscillates between 1 and -1, so this limit does not exist. Thus the answer is D, any does not exist. Yeah, I like this kind of short form. And yeah, so that is pretty much all for this one also. So I'll just write correct solution. Good work. And basically this same thing will apply with cosine also. In fact, secant and cosecant also. Just a minute. Yeah, so this will be question number 5. So here it is asking for the integral of cosine x. So we need to calculate integral of cosine x dx. Now the thing is that I directly know the integral of cosine x, but I'll just go with the derivation given by Janine The Tutor here. So yeah, to determine the integral of cosine x, we have formulas used, fundamental theorem of calculus. Suppose f is continuous on a and b. Like this is, oh god, trigonometric rule of integration. They have directly given the answer also. Trigonometric rule of differentiation. So for solution, okay, so I'll just follow this procedure because clearly we haven't like ever seen the derivation of such kind of integrals, because we directly know if differentiation of sine x is cosine x, then integral of cosine x will be sine x only. But let's just follow this derivation and see that where will we end up. So here they are writing cosine x is equal to derivative of integral of cosine t dt, and the minimum value is -pi, positive is x. So we'll go for the integration false here. So this will become, like, I don't understand what is the there is no sense of integration here, because like in the first step we are finding the integral of cosine x, and to find we are doing another integration, and here we are already writing the integration of cosine t dt as sine x plus c. So this doesn't make sense at all, but I'll just do this because it is mentioned here, and obviously it must be mentioned in some kind of book also. So integral of cosine t will be sine t. This will become sine t from -pi till x. This will be d dx of sine x minus sine of -pi. Now sine of -pi, sine of 0 is 0, sine of pi is 0, so sine of -pi is also 0. So this term will be 0, and this will become d dx of sine of x, and again derivative of sine x is cosine x, so this will become cosine x, and hence LHS equal to RHS, and therefore we can say, so the integral of cosine x is nothing but sine x only. And yeah, for indefinite we'll have a plus c, for definite we'll have some value of c, and that c can be 0 also. So this was question number 5, I guess. Yep. So I think that is pretty much all for this one also. We'll be moving for question number, this is 6. Mm, Use the chain rule to find the indicated partial derivatives. So we have few functions here. U equal to x e power ty, x equal to alpha square beta, then y equal to beta square gamma, then t equal to gamma square alpha. And then we need to find del u by del alpha, del u by del beta, del u by del gamma when alpha equal to 1, beta equal to 2 and gamma equal to 1. Okay, so the thing is that this u is a function, we can clearly see that u is a function of x, y and t. Okay, and then x is function of alpha beta, y is function of beta gamma, and t is function of gamma alpha. Now first what we'll do, we'll calculate x, y and t when alpha for these given values of alpha, beta and gamma. So for alpha equal to 1, beta equal to 2 and gamma equal to 1, we'll calculate x. So x is alpha square beta, 1 square into 2, 2. Y is beta square gamma, so 2 square into 1, this will be 4, and t will be gamma square alpha, so 1 square into 1, this will be 1. So I'll just write the values which we'll be using afterwards. So alpha equal to 1, beta equal to 2, gamma equal to 1, x equal to 2, y equal to 4 and t equal to 1. Now we are going to use the chain rule here. So basically we can clearly see that u is a function of x, y, t, and so what we'll do, del of u over del of alpha, in the first one it is given alpha is going to equal to I'll write alpha only. So this is going to be equal to del of u over del of alpha plus del of u. Just a minute. This will be del of u over del of alpha, del u over del x. Okay. So yeah, u was a function of x, y, t, right? So this will be del u over del x over del alpha plus del u over the second one is del y, then del y over del alpha plus del u over del t over del alpha. So I'll be using the equations from here only now, from now. So I'll write del u by del alpha is um, 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 del u by del x. So del u by del x is going to be um, times del over del alpha. X is alpha square beta plus del over del y, again u is x e power ty times del over del alpha, and here we'll write y, which is beta square gamma, and then again plus we'll have x e power ty del t, then it will be del of gamma square alpha over del of alpha. So now let's calculate. So for in this case, in partial derivatives, we first in the case of this one, we'll differentiate this with respect to x and we'll keep all the other variables as constants. So here x is taken as the variable and e power ty will be a constant term. So this will become e power ty times, and here again we have again we'll keep beta constant here, so this differentiation is with respect to alpha, so this will become 2 alpha beta. For this one we'll differentiate with respect to y, and x and t will be constant, so this will be x, and t is a constant, so it will become t times e power ty. And now for this one we do not have any alpha, so the and beta and gamma are obviously going to be treated as constant, so we'll have 0 here, plus for here also we'll do the differentiation with respect to t, and y and x is constant here, so I'll write um, x times y times e power ty, and here alpha, so this will become gamma square. Final expression will be e power ty alpha beta plus um, xy e power ty gamma square. Now we'll put the values which we obtained previously. So we'll put alpha beta. We'll put these values here in the in this one. This is 2 times e power t was 1, y was 4, then alpha was 1, y is 4, beta was given as 2, so 2 square into 1 here. Okay, and then e power t was 1, y was 4, alpha is 1, beta is 2, plus x is 2, y is 4, then e power again ty will be 1 times 4, and this will be gamma square, so this will be 1. So this will become 2 to the 4, e power 4 plus 2 4s are 8. I'll just see that whether they have um, e power minus 4. Alpha is minus 1. Oh god, so alpha is given here minus 1. If alpha is minus 1, then my t will be -1, and I'll also write this alpha as -1. So t will be -1, then here alpha square was there. Okay, so here I'll just correct this. This will be minus, and this will be minus, and 4 plus 8 will become 12 e power -4. I'll again just cross check with the solution given here. It is given. Okay, so I have to put the values also. Okay. So here I'll put alpha as -1. This will be -4. Okay, these signs are not printing and it is creating a lot of confusion here. Sorry, 4. It will be 4. I'll just write this 4 again. 4 times e power -4. Here there was no alpha. Okay. T was not there. Okay. So this was the value for del u over del alpha. Um, so we'll go for the second one, which was del u over del beta. Again, del u over del beta will be del u over del x over del beta plus del u over del y over del beta plus del u over del t over del beta. This will be del u over del x. So I'll just take the values from here only. So del u over del x was e power dy. E power dy. Then it is del over del beta of del over del beta of x is alpha square beta plus this was x into t into e power dy, xt e power dy times del over del beta of y was beta square gamma plus xy e power dy and then this will be del over del beta of t is gamma square alpha now this will be alpha square plus xt e power ty. This will become 2 beta gamma. So 2 beta gamma, and this will be 0 because we do not have any beta term here. So plus 0. Now again we'll put the values of alpha, beta, gamma and xyt. So e power minus of 4, alpha square will be -1 square 1 plus this will be 2 x. What was x? X was 2, y was 4. So x is 2 and then t is -1 then e power minus 4, beta is 2, gamma is 1. So this will become, I'll calculate, this e power 4, and this will be minus of 2 to the 4, 4 to the 8, minus of 8 times e power minus 4, so this will become negative 7 e power minus 4. Let me just cross check this. Yep. So negative 7 e power minus 4 is del u over del beta. Okay. This is a very lengthy question, I guess. Yeah. So I will go for the third one. Del u over del gamma. So this is again del u over del x over del gamma plus del u over del y over del gamma plus del u over del t over del gamma. Again, I'll take these the values of del u over del x, del y over del u over del y, and del u over del t from the above equation. So this was e power ty. E power ty, and this will be del gamma of x is alpha square beta plus x t e power ty del gamma of this was y is beta square gamma plus plus del u over del t x y e power ty. Then this will be del over del gamma of t is gamma square alpha now I'll do the differentiation. So this is e power ty, and we do not have any gamma term here, so this will be 0 plus x t e power ty, and gamma is, so this will become beta square plus this will be 2 gamma alpha. So 2xy e power ty gamma alpha. Again we'll put the values. So e power ty is, this will be 0. I'll drop this. So x was, again I have to go 2 4 minus 1. So this is 2 minus 1 e power minus 4 plus 2 2 4, and we do not have any d. Okay, now beta was 2, so beta square will be 4. Here e power ty is minus 4, gamma is 1, and alpha is minus 1. Oh, both the terms are in minus here, I think. Yeah, I guess both the terms are in minus 1. So this will become 2 4s are 8, negative 8 e power minus 4, and this will become 2 to the 4, 4 to the 16, negative 16 e power minus 4, and this will be 16 plus 8, negative 24 e power minus 4. Oh god, this question is very much lengthy question. I'll just check with the solution. Negative 24 e power minus 4. So just at last I'll just write all the three answers. So del u over del alpha was 4 e power minus 4. Del u over del beta was negative 7 e power minus 4, and del u over del gamma was negative 24 e power minus 4. Seriously, this was a very lengthy question. It took around 2.5 pages. So I'll just write the solution given here is correct. Final answer is correct, and again I'll just check the procedure. Del x by del gamma, del y by del gamma. Okay. Steps are also correct here. Okay. So the solution given here is correct. Correct solution given here. I'll just write correct solution. This was question number 6. We have question number 7. So how to convert between polar and rectangular coordinates? Okay. So I'll just see the solution. Oh god. I'll just explain it. We need to convert between polar and rectangular. Okay. So I'll just draw a coordinate system, and let's say we have a point P here, and let's say this is this is y-axis, this is x-axis, this distance is y, this distance is x. So this will be yeah, pretty much this one only. So in a rectangular coordinate system, basically we represent the point in terms of this distance x and y, or the perpendicular distance of the axis. So the coordinate p will have x comma y as their coordinates. Okay, let's say x1 y1, and the equation for this will be, so if I draw one line from here, and then we can clearly see that this is a right angle triangle. So I can write this as, so let's say the length, this length is r. So using Pythagoras theorem, I can say that r square is this x square plus 5 square. So this rectangular coordinate system is also called as Cartesian coordinate system, and like in practical engineering problems, we mostly we use Cartesian coordinate system. But yeah, I have encountered some problems where we have to deal with what we say that radial fields or some tangential fields. In that case, we had to use cylindrical or so spherical coordinate system. But here Cartesian coordinate system is given, so this is the Cartesian coordinate system. Now let's say this angle as theta. So in rectangular coordinate system, we represent the coordinate in terms of this distance, x and y distance, the perpendicular distance from both the axes. So this was rectangular, and for polar coordinate system, we take the length of the this line which joins the point from the origin, and we take the angle between that line and the positive x-axis. So in polar coordinate, we represent this as r comma theta. Now if this is r, this is theta, then I can write cosine theta will be, this is base and perpendicular, so base is x, perpendicular is base is x and hypotenuse is r, and I can write sine theta as this is perpendicular opposite, so this will be y over r. So I can write this as x equal to r cos theta, y equal to r sine theta. So we have already, like you can see that we have already obtained the conversion for the rectangular coordinate system to polar coordinate system. So no, not so. We can use these two expressions to convert this polar coordinate system in Cartesian coordinate system. So if we have the value of r and theta, then we can calculate x and y. But for reverse, what we do, we keep the value of r and y in this equation. X and y in this equation. So we'll get r square cos squared theta plus r square sine squared theta is equal to r square. And then we can write 1 equal to plus sine square theta, which is the property of trigonometry also. I'll just, on the other hand, the same point is can be represented r comma theta instead of this. Then they have r square equal to x square plus y square, so cos theta. So x equal to r cos theta and y equal to r sin theta. So I think that is pretty much all. Like in this whole, all these statements are just the same, which I already told you. So I think yeah. So in this way, like we convert polar coordinate system to rectangular and rectangular coordinate system to polar coordinate system. So that is, I think that is pretty much all, and I'll just write correct solution given here. We have, I think we have another question. Okay. So this is question number 8. I will start with black. So we need to find the derivative of sine inverse of square root of x. So we'll find this derivative using substitution method. So first we'll substitute square root of x as u, then I'll differentiate on both the sides, so I'll get dx, and this will be 1 over 2 square root of x equal to du, and I think, yeah, so du over dx will be du over dx will be half of square root of x. We'll use this, and I know that the derivative of, let's say, sine inverse of t is 1 over square root of 1 minus t square. Now first I'll just substitute this, so this will become, first I'll substitute the value of u, so this will become sine u, and we have to calculate we have to find the differentiation with respect to x. So what we'll do the differentiation of sine u with respect to u multiplied by du over dx. So du can get cancelled, and we'll end up with the differentiation with respect to x only. So I'll use this. So this will become 1 over square root of 1 minus u square times, and du by dx was 1 over 2 square root of x. Now I'll substitute the value of square root of x back here, sorry, u back here. So this was 1 over under root of 1 minus square root of x square, and then this will be 1 over 2 times square root of x. I'll just multiply the square root of x and with this one, so 2 times square root of x will go here, x minus, this will be just a minute, so this will become square root of x, I just need to check this, 2 root x is square, so this will become x, and this is square root of x will be multiplied, so yeah, square root of x will be multiplied with this one also. So this is x into x, this will become 1 over square root of 2 x minus x square equal to d dx of sine inverse of, yeah, so that is the final solution. So yeah, in this way we can also calculate for cos inverse of x and other inverse trigonometric ratios. So that is also pretty much all, and I'll just write correct solution. Yeah, so that was that was all for this session, and if you like this session, then please do hit the like button and do subscribe also, and please do hit the bell icon so that you'll always be updated for our next live streams. And this was Devansh, senior tutor at OneClass, and yeah, if you need any tutoring help or if you want to submit your own questions, then you can check the links in the description below, and I hope to see you soon in my next stream. So till then, bye.